Thank you very much for inviting me to talk today. It's a real honour to be here. As Kathleen said, I did this analysis. For one of the first biochar meetings, I'd seen Bruno give a talk at the University of Vienna about biochar. And at the time, I was working for the FAO IAEA in the Soil Science Department. The FAO IAEA is a food and agriculture organisation, and the International Atomic Energy Agency, and we were working very much with using isotopes to sort of trace fertiliser use efficiency, carbon sequestration, etc. And Bruno came and gave his talk on biochar at the University of Vienna, and I found it a fascinating subject. So thanks to Bruno for inspiring me so much. And obviously at the time I'd done very little biochar research. At that time it was still very, very new, and I thought, well, what can I bring to this conference if I haven't done any biochar research? And at the time I was struggling with doing an MBA through the Open University of the UK, and I thought, I know what, I can kill two birds with one stone. I can do my biochar analysis, business analysis, and I can submit that for my assignment, and I can also submit it as a poster for the conference. So this is what this analysis comes out of, really. So please bear with me if you're not used to more business analysis type stuff. First of all, the first thing you always do in a business analysis is you always do a stakeholder, sort of just really to find out who's really working with you, who's working against you, who are the people, who are the actors playing in the area, and this can sometimes come up with really interesting people, and it just gives you a general overview of really who's working with you and against you, and people that you need to take into consideration. So obviously here we've got politicians, governments, carbon managers, farmers, foresters, soil custodians, etc. As Kathleen said, all these people will be on, all these slides will be, or most of them will be on. So don't feel you need to, but you feel free to take photos. They've been on the web for almost 10 years now. So the next thing you do is you do a steep analysis.
I don't read it.
You do a steep analysis, and from my perspective, what really impressed me about biochar is it fulfills so many criteria in terms of steep analysis. It is very socially acceptable, and at the time when I wrote this, I was I was just going with sort of gut feeling. But since I was saying earlier, we have this science communication project called Biochar Net to You. Net is negative emission technologies, but in Austrian net is also nice. So there's a bit of a play on words there. But since we've had that project, I've realised that the social acceptability, people are very, very comfortable with biochar because they just see it as charcoal and they're very, very comfortable with it. So that's really quite a huge thing for biochar. People don't associate it with risk. Also, this whole idea of providing a market for waste product is very socially acceptable. Obviously, the technical side, there are. I did this analysis from an Austrian perspective, and Austria is well known for its sort of like technical excellence and experience of small-scale solutions. From an environmental point of view, carbon negative energy technology, this carbon neutral type of things, greenhouse gas emissions, a lot of these we've talked about before. From an economic perspective, I think one of the things we really have to remember is we're really in the earlier adopter stage with biochar, and one of the big things is that early adopter, I worked a lot with starting the solar revolution, I would say. And we started the solar revolution like 25 years ago, and it was hard work. And one of the biggest problems with starting the solar revolution was trying to convince people of the economies of scale, that as you get more and more production units, that the price per unit goes down. And this is exactly the same case in biochar production. As we get more and more biochar production and the technology becomes richer and richer, the actual unit price of biochar production will come down. It's very much the same thing. And so that's one of these barriers that we have to get over. So we have an earlier adopter. We feel we have an early adopter advantage here in Austria in terms of technological sales. We tackle two problems with one approach, this win-win scenario. From a political point of view, well, at least at that time, we were in a very different political space. In 2008, we were in a different political space. But it was still fairly easy to sell it in terms of energy. It does make sense. Biochar does make sense. Even today, it makes sense. Whether people believe it or not is hard to say for everyone. I think we can easily sell biochar as a very winnable technology. So talking about this whole idea again, from a very business perspective, business is often seen as in terms of diffusion of the innovation. And obviously, fertilizer technology is really a lot of people know about fertilizer in agriculture, etc. This is just an example. That everybody knows what fertilizer does, but in fact, biochar is only in 2008. It was really only the innovators. I put that mark there at that point. Actually, I think we were in 2008. We were a lot further in the innovator sector. Now I think we've gone much higher, but still much higher. I still talk to students, and often I'll have a whole room of students, and only 1 or 2 people out of 40 people will know what biochar is. So we've still got a hell of a long way to go, I think, until we get to this, to the level of fertiliser in terms of biochar production, or in terms of people knowing what biochar is and the benefits of biochar. I think one of the things that we misfired when we first started looking at biochar was to look at it from a typical sort of retail aspect, and not really understanding that there's these push-pull market forces in biochar production. I mean, we're so familiar with the push market strategy that you sell a product and you promote that product, and that just isn't the case in biochar. Biochar is a really very defined product that people will need, and we have to create that desire and that need, and that it fulfills certain criteria. And that there needs to be a pull demand rather than a push demand. Biochar isn't one of these spontaneous purchases that we have. And we have to think very much about how we create this pull by creating different multi-purpose biochars. And think about the value of the biochar and how we can create added valued biochars in the end of the day. The other thing that comes out of this is that this idea of the customer within biochar, the customer is not always the consumer for biochar and some of the value chain products of biochar. The consumer is not always the customer either. So it's a very important thing for us to remember. So just to point out that this push strategy doesn't work, we have to really focus on the pull strategy. Another thing we do when we do these market analyses is we do a full market analysis, and we look at supplier power, threats of substitutes, and this is a big one, I feel, in biochar production, especially given the fact that the sort of like the solar revolution and the wind revolution have taken over, where that they come in as fairly large substitutes. Since 2008, a lot of these substitutes have probably gone off the table a bit. Nuclear because of Fukushima, oil because of global warming. Some of the bioengineering, although they had very sort of positive and very, they're still in play, but to date, bioengineering has produced very few carbon neutral strategies, if that's the only direction we're going in. As I say, to think about consumers and customers, we have to think about our customers as policymakers, carbon managers, farmers, foresters and soil custodians. And I think since this, and I think also Kathleen pointed out that actually this list should now be extended. We were very much focused on an agricultural biochar, as now we see the multi-purpose applications of biochar, and our customer list could be expanded quite heavily. And in terms of supplier power, that there are many carbon mitigation strategies suggested. At the time, geoengineering was really hot. I think, again, that's gone off the table to some extent because biochar is a ready-to-go technology and it has huge potential, especially if we're talking in terms of carbon sequestration. An industry rivalry. At the moment, I think there's still, one could say, few biochar producers around, so there's still very positive ways, or positive places to go. I see within Austria, I think there's a huge opportunity in the thermal energy sector, being cold in winter basically, when solar power and wind power really are a bit more tricky to tolerate in winter months. There's a huge opportunity in the solar energy sector. And just to put this into a bit of perspective, I have solar panels on my roof, and I actually only produced, to date, I've actually only saved 2 tonnes of carbon, and I've had the solar panels for 2 years. And I'll show you some data for biochar later, where we've added 50 tonnes of carbon to the soil in one go, and we've had no effect on yield. So they're really big things.
You've had no effect on what?
On yield. But I'll show you those data in a minute. And obviously one of the other things we really forgot to think about was this risk factor and what the perception of risk. So when we look at biochar, we look at the drivers, when we look in management perspective, we look at things, the drivers and the resistors of change. And for me, it's always more important to look at the resistors of change, because the drivers are fairly clear. We have got climate change, carbon mitigation, we've got positive soil conditioning effects, we've got large waste streams. At the time in 2008, it was a really new concept. Biochar was a really new concept. It was way out of most people's comfort zones. They really didn't know what they were doing. There was a lot of unknown risks, and I think where the research has really added to the knowledge, and those unknown risks are now becoming known risks. Unknown interactions with fertilisers, again, there's been a hell of a lot of research, fortunately, and so we're really covering those areas. But one area where I don't think we really realised there was such barriers were things like legislation and organic acceptance. Policy and legislation have really caused a stuttering of the biochar business development, I would argue. And I think they're things that we really still need to address, but I know they're all ongoing and they all take time, but it really is one of those things that will definitely improve in the next years. So as a soil scientist, what's our raison d'etre? Well, I'm a soil scientist. I should really be focusing on the soils part, but I think I should always have an eye on the business side of things. And our mission, vision, value. Well, for me, carbon sequestration is always a huge thing. But what can we provide? What can we do? Quality scientific data. I think that one of the problems for me when I look at biochar, I see so many ad hoc experiments that are really not written from a scientific quality perspective, and I think we really have to push that to gain people's trust. And so that's where the research organisations come in. Who are our customers? Our customers are the scientists and the policymakers, the general public and the farmers. And what are our core competencies? Well, our core competencies are measuring soil processes that have global relevance, communicating those findings in a scientific manner to the policymakers, and agricultural and environmental modelling. That's what we can do as soil scientists. So now I'm going to give you a brief overview of some of the work that we've been doing in this regard. And there's so many people to sort of to acknowledge within this work, that they'll all be at the end. So read carefully at the end, the last slide. So this is a project was started after I'd seen Bruno in Vienna University, and I got funding to do an Eliza Richter Fellowship, which is a fellowship given by the Austrian government. Unfortunately, fortunately, I got to go to Kenya to work on a project that had been started by then the Tropical Biological and Fertility of Soils group with Bernard van Loire and a group there where they'd applied charcoal to soils, and a group from SLU were also involved charcoal to farmers' soils in Kenya, and they had applied charcoal to a number of farmers' soils across Kenya. As you can see from the photos, we got phenomenal responses, and I was so blown away by this. By these responses, basically because Bernard and I had been working in tropical agricultural development for quite a long time, trying to get soil carbon back into soils, because it's the basis of all soil fertility in Africa, and we had struggled year after year after year to get carbon back into the soil. The farmers never wanted to see beyond their harvest horizon. They were interested about what was going to happen at their harvest. They're not interested in about what was happening in 10 years' time. And it was the first time that biochar, for me, it was the first time I saw something that you could really impress a farmer at their harvest horizon. And so therefore it was really quite impressive stuff to us. Huge amounts of biochar were added in these first trials, but we got these amazing results. We got really quite amazing results for Africa. We got doubling to tripling of production on decadal means. And when we only added 30 kilos of nitrogen fertilizer. We got really quite phenomenal yield increases in these systems. We did a lot of very detailed process measurements, which I'm not going to go into because I don't think everybody wants to listen to gross mineralization experiments, but we did a lot of very detailed experiments on the nitrogen turnover and the carbon turnover in these soils. But the end take-home message was when we added biochar, we got far more available nitrogen in these systems, and that's what was driving the production of these systems. The other beautiful thing when we did these tests is we really improved the amount of carbon in the soil, and we could detect those improvements in the amounts of carbon using stable isotope techniques. So it gave us a validation methodology as well, so we could see that biochar was being added to the soil in these systems. So it sort of feeds into these REED sort of processes and for doing what carbon accounting. Don't ask me. I'll go look it up. It's all these regulations for doing carbon accounting. It's a UN thing that is for. I'll find it for you. Sorry. One of the things in Africa, you could ask why is fertiliser such an issue in Africa? Apparently 50% of the cost of fertiliser goes on after it's left the factory. And one of the reasons being is the sort of port charges, land transportation in Africa because of the very difficult roads, marketing and distribution. Because it's a very high demand product in Africa, there's a lot of markups, there's a lot of underhand, there's a lot of cutting of fertilisers, etc. And then there's also access to finance. Finance is a big issue, 30% interest rates, women being very much the mainstay of African agriculture, and often the mainstay of sort of like the feed production in the family or in the livelihood. So they're all really important parts of this. And so with this in mind, Bernard set up a project to look at biochar, using biochar based on the work of Lehman and Thies, using biochar in a cooking stove system. They'd done some tests so by this time Bernard van Loire had moved to IITA, which is the International Institute of Tropical Agriculture, and he was interested in sort of converting from this 3-stone traditional sort of energy system to a biochar cook stove system, and setting up a project there. And so the project was set up in Uganda in 2015. Initially, 60 biochar ovens were given out to test. So this was the Mark II, but initially we had different. These are Chico's, what's called a Chico. We can see it later in the thing. What we wanted to do was test the acceptance, as we saw these were a real entry point into tropical agricultural, bringing biochar into tropical agricultural systems. Obviously, if you do something like this, you have a lot of risks. There's a hell of a lot of risks. And one of our big worries was, so we had a big open day where we had a participatory approach meeting where we had 60 farmers took their own biochar kiln, and then those biochar ovens were tested in the farms on farm around Uganda, and the farmers had to keep a record of the different produce that they were, the different biochar fuel stocks they were using in the system, and the different rates of like wood use, etc., and usability, So, but I had a lot of worries about things like carbon monoxide poisoning, about PAHs. So we came in from that perspective and looked at that side of the process. So this biochar oven, as I say, is the first. The Mark I was produced by the Lehman Group. The Mark II, it was iterated based on the feedback we got from the people from the farmers and the women that were working with the system. So it's a 2-chamber system with a biochar production system on the outside, so the pyrolysis system on the outside and the combustion chamber on the inside. And then you put the pot on the top. You squeeze it down and you put the pot on the top. Now, I'm not saying that what I want to stress here is this is a stepping stone technology. At present, there's a huge number of people, something like 1.5 billion people use biomass energy to cook with. We're not saying it's the best technology in the world, but it is a stepping stone out of poverty. So I really want to stress that it's not what I would say is the perfect technology, but we're getting there, because the majority of people are still using a 3-stone stove in these smallholder African farming systems. So what we wanted to do was compare these two technologies, to compare the 3-stone stove with our new biochar system. So we used what we call the Stanford water boiling test, which is a water boiling test that was developed by the Stanford Group. And I'll just give you some brief overview. So we used it for the biochar production, for the external biochar pyrolysis part. We used a rice husk, which is something very, very unbelievable actually in Uganda, but it's very, very common in Uganda to have a lot of rice husk, because there's a lot in the part of Uganda we're working with, there's a lot of wetland rice there, and rice husk wastes are a big problem. They pile up in the area. The other thing we used was coconut shells, and then we tested it. We have all these low-cost sensors that you can see the system up in the top corner here. We've got this lab, here's Sarah doing all the tests. We've got this lab construction where it's sucking out all the air, and we've got the sensors for CO2, nitrous oxide, particulate matter, carbon monoxide, SO2, and we're testing all those gases in this sort of low-cost system that we developed with a group called Vienna Scientific Instruments. And what we found was that our biochar system, this Chico, this newly developed Chico, uses 35% 36% to 40% less wood than the three-stone stove. It emits 24 to 33% less CO2, 67 to 33% less PMs, so these small particulate matters, which are a really big problem in Africa, and it emits 8 to 28% less CO than the three-stone stove. So it was really useful. Also, what we've seen that they're very well accepted. People love these. We initially, to manufacture these in Africa cost us about $100 a shot, which we keep saying we probably got the Mzungo price because we went as researchers to the blacksmiths. They probably said to us, "Oh yeah, they saw us coming," basically. But anyway, we then, after the trial, we resold. We said to the people, after 3 months of the trial with the system, if you want to, you can buy the Chico back at half price, so $50 a shot. And something like 80% of the people bought back the charcoal oven. It was that valuable to them, and $50 is big money in these areas. So it's really very impressive what they could do. And so we're in the process of modelling this data up to an African basis, and we are looking for sort of like for investors or somebody, some sort of social enterprise to further this work, because we think it would be it's a real entry point into so it's a real win-win scenario for African development. So that's the work on the tropical side. I think all of you know about Jeffrey et al. And them talking about, it's great, biochar is great for tropical and developing countries, but not for temperate yields. And I would totally agree. I would say I would totally agree. But I think what we fail to realise here is, from a temperate perspective, we're looking for different utility. From a temperate perspective, we are looking at carbon sequestration, and that's where we're really coming in with biochar, what the potential of carbon sequestration is. Now, I'm going to give you this, probably going more into Marcel's direction. This is a picture of Austria at the moment with all the different heating plants and the CHP heating plants in Austria. These are combined heating power plants in Austria. And these are very small scale. These are like a village or community scale heating plants. So in Austria, most of you know, it's something like 80% forested. So it's got a very high level of forest products. And if these biomass plants could be converted to biochar plants, it would be fantastic. And so. Here we also have, and there's specific regions in, for example, in Oberösterreich that have many of these biomass plants. They're just basically combustion plants, and we feel that there's a real potential for these to be converted to biochar systems. And why do we feel there's that potential? Well, we did some studies with Gerhard when I was previously at AIT as well, and at the University of Vienna with Gerhard, and we worked on a couple of sites doing field experiments. And I'll just quickly go into the sort of the background of the field experiments. There was one just to the north here and one in Kindorf, where we added again fairly large amounts of biochar. But what there's one in Kindorf. What we did, my role in the experiment was to look at the use of nitrogen 50, or the use of fertilizer within the systems. So I was using a stable isotope labelled tracer to look at the nitrogen interactions in these cropping systems, and to look at where the fertilizer nitrogen was going, basically. And I'll only present a very small part of the work that we did there. So in these systems, we added 72 tonnes of biochar per hectare in the BC3 and the BC3N biochar in those treatments. Obviously, we could only compare using the 15N fertiliser to look at fertiliser use efficiency. we could only compare the BC3N versus the NPK, so that's plus biochar plus fertiliser plus against fertiliser alone. We used a labelled fertiliser, so that allows us to trace exactly the fertiliser uptake in the plant. Also, it must be pointed out, we only did we did the top dressing of the fertiliser. This was just down to pure logistics and problems with adding labelled fertiliser to the system. We were basically piggybacking on Gerhard's experiment, so we didn't really want to take over his experiment. As you can see, it was already quite squashed anyway, so I didn't really want to sort of encroach too much on his main experiment. But what we saw from these examples was, in fact, that when we added the biochar, we had expected to see large increases in yield. I don't know why. I think we were quite naive maybe at the time. But what we did see, and I think is really sometimes very underestimated, was we didn't actually see too much move in yield at all. However, we had added huge amounts of carbon to these soils. And we know when we add carbon to soils in a raw form, we get huge amounts of nitrogen immobilisation. If you add something like sawdust to a soil, any gardener will tell you, you get immobilisation of the nutrients. The plants don't grow because they're so stunted because there's no nitrogen there. And so it was quite incredible for us to see this. The other effect we did see when we had a very dry year was we saw that the plants were dealing much better with the drought, and we could see this from our C13 signatures. If anybody wants to talk to us about that later, I'll explain it. I don't think it's really for here. Although we saw better uptake in the biochar treatments from the fertiliser, there was some compensatory nitrogen uptake, so we didn't see a yield impact on the fertiliser. But we saw this effect, or this non-effect, of adding these huge amounts of carbon to the soil had very little impact on the yield, as you'll see in both sunflower the year after in the Treis-Mauer experiment and in maize in Keindorf. So we saw some the nitrogen derived from fertiliser in the Keindorf experiment was a tiny bit lower in the maize treatment, but that could be, but it really was 4 kilos per hectare. Is nothing. I'm not writing home about that, and it is not one of those areas that we need to worry about too much. The big take-home message here is, though, that biochar application to soil at 50 tonnes per hectare did not cause any or very little immobilisation of nitrogen, which is phenomenal, absolutely phenomenal. So obviously, if we start thinking about that impact, and what we have to do is think about our food systems differently, to put value onto the subject, to put value onto biochar. And I think this is really, somebody alluded to this earlier. This last week in Nature, there was a big article on smarter metrics will fix our food system, and I think biochar fits very much into this. And if you go to the Nature website, web page, actually, there's a really nice video from Johan Rockström, the guy from the Resilience Centre in Copenhagen, talking about smarter food metrics. And once we start to value all the other aspects of our food systems, biochar really comes into this food system, it comes really into this area very, very strongly. The value of biochar is really put up there. Because if you look at it from a global scale, we've got climate change mitigation, we've got increase in carbon sequestration, maintenance of bio. We've got a national scale, we've got workforce aspects that are often not valued in to our metrics of food production. Our metrics of food production are usually just purely yield, and as they point out, as Pavan Sukhdev points out, that in so many other areas, in economics, for example, GDP has been seen as a really is not a particularly good metric for economies of countries, that we should be looking at more diversified metrics. Things like levels of happiness are much better metrics for determining country well-being, etc. And that in so many other areas such as health, economics, etc., that we're looking at these new metrics, and really we should be looking at using new metrics to study our food system. And I think with that I will give up. And I think that's it like that. Give big thanks to all my contributors and all the people involved in the project.
Why the big word trust?
Why the big word trust? Because I think a lot of it, this whole competitive advantage thing, is a lot of it is down to trust that we've got the right results, trust that we're doing the right thing. I think a lot of the time we're working with risk, and people don't like risk. So that we're not trying to sell something that people don't want. I think perception of risk is far higher, and I think this is one of the beauties of biochar, is people don't perceive it as a very big risk, as opposed to something like nuclear power or something. Biochar has got a very unique position in that regard, that people, or GM for example, has a very high risk perception.
Your message to the general public is trust biochar?
Well, no, I think we have to develop that trust. I think we as scientists have to foster trust, I would argue.
Rebecca, about 15 years ago I was in Brazil, and I worked for the aluminium industry, and I was looking at this map in an area that Alcoa was about to open up a new bauxite mine, and one of the guys next to me said, "Peter, there's the words Terra Preta." And so this wasn't an area that was about to be mined, but we went out and had a look at it, because I said, can I have a look at it? And here were these peasant farmers still farming this dark soil, and successfully growing crops, even though they'd lost the skills that their forefathers had put that charcoal in the ground. So the business case for them was they had this rich soil that was still productive 500 years later. We tend to do these sort of trials on 1-2 year funding, 3 year funding or whatever. The thing I was hoping for at the end of this was that you'd make some business case for biochar in Austria that had some dollars attached to it. I believe all these things about making soil healthier. That's why I started too. But I'm amazed that none of the results so far have enabled you to put up a slide there saying, well, here's the business case.
Well, to be quite honest, I'm actually a soil scientist now, not an MBA student. So I think it's just where I put my money, where I put my efforts. I mean, we are for the African one, or for the Ugandan example, we're definitely we're going in that direction very much so. But it just takes, we need to get all the numbers in to start with to do that.
But those plots that you put 10 tonne per hectare in Austria.
Like 50 tonnes of carbon.
If we went back there today and next year,
we still find the biochar there.
The char will still be there.
Yeah,
will the soil be healthier?
The soil has changed. I mean, I don't know if we'll go to the site in Keindorf, but the site in Triesmauer has been converted to a vineyard. But we've been back since, and we've gone and got the soil, and we can still find the carbon back there. It's still there. I mean, we know that we can see directly from our carbon measurements that the carbon is still there. It is fixed there. From a soil health perspective, we just haven't had the money to look at it. We have put a grant in to have a look at that aspect of those soils. But I mean, a lot of these things is always getting the money to do the research is the hardest bit. Actually, the actual research is the easier.
Peter, I would just say it's very hard to generalize even with one crop, because one year, if you have drought, it's the difference between having any crop and not. But the next year, if you have good weather conditions, the yield difference may be very different, and that's in one country very different from another. So I think there's a lot of hesitation to publish these
and getting field data published is so difficult.
Yeah, Well,
I mean,
even
it's just
outside
like
of
those
peer-reviewed
things.
literature, I think in the general grey literature, people are reluctant because of so many variables.
I mean, these are our 10-year. These are about 10-year. They're decadal means. I mean, they were all over the place for the Kenyan soil, but it's on our farmers' plot. I mean, but they're pretty impressive, I would
That
say.
data is Uganda.
Pardon? This is actually Kenya. No, this is in the foothills of the of Mount Kenya in
If we
Embu.
could put Peter's question in slightly different words. If I pretend to be a Kenyan farmer, I
Yeah.
don't do very well, and you come to me and you say this, and I can believe all of this, but what I have to do, the decision I have to take, is to make a large investment with a long-term payback. But it's an uncertain long-term payback because I happen, as a Kenyan farmer, to have read a paper about a finding in Kenya where in 2 plots of maize close together there was a yield increase which was commercially significant. In the third, there was a substantial yield decrease. So now I'm going to say to you, what model can you present to me to give me some sort of estimate of the risk and the value if I make this investment? If you're putting 50 tonnes per hectare, that's an enormous investment.
Oh yeah. I mean, I worked it out. It's something like €10,000 €10,000 a hectare.
Fine.
But
let's-
this is where this comes in. This is.
oh no,
this-
that's great stuff. But that's not going to put any amount of biochar.
We can put a tonne per hectare per year. That's what we've worked out. Approximately a tonne per hectare per year can go in through this system.
Per family.
And obviously, pardon?
Per family.
Per family. If they're really, I mean, yeah, that's the argument.
But then they're using 3 or 4 tonnes of biomass for their cooking.
Yeah, but I mean, the numbers that I showed you there are run using the standard Stanford boiling tests.
Yeah.
Our anecdotal evidence
But where does this
is
feel-
much better. It's much better. So we're reducing. So we've got multiple benefits along the supply chain because we're reducing the time that you have to do wood gathering, using a product off the farm. Yeah. There are multiple benefits associated with using this system. And that's
can
why we
accept
want
all
to
of that, but I'm still feeling that we're stuck in this loop of doing isolated small-scale experiments without, as Peter says, trying to work out what the economics are on a bigger scale. If I'm this Kenyan farmer, what can you say to me about the economics if I were to find some way of making this investment?
Well, you've doubled your yield. I mean, this is irrelevant. I think it is really the long term. We have to get the research funding to do those big term experiments.
You're
We've
talking
done
about research funding. I'm talking about trying to get through to the stage where there's sufficient practical knowledge.
Yeah,
People
right,
are
okay.
informed.
So
We've
the-
been actually stuck in this position.
No,
for
but
about 10
this
years.
ADA project, yeah, this is done on 40 farms across. We've had there's a parallel part to it. One, but we did a hell of a lot of testing about where all the supply products are, what the potential feedstocks for the biochar ovens are, and the other part was to trial on, I think it's 40 farms across Uganda. I mean, it's a whole nother presentation. 40 farms across Uganda, just adding biochar at 1 and 5 kilo per hectare rates on 4x4 field. So it's a big scale, in some ways a big scale project. And what we've seen is we've got some benefit, but 1 to 5 tonnes is very small amounts. But you get the benefit if you add it. I mean, this is possible in these small farming systems. If you add biochar with manures and you add it per plant almost.
Yeah.
But most of these systems are 1 per hectare. And we've just got to convince, I mean, you know what these things are like, convincing people. It's so much easier to take something like a GM seed or something rather than a soil practice, a soil management practice is so much more complex because it's so much more contextual. And this is the problem. This is where we really face a lot of problems in soil science, is that trying to get something such as a biochar management practice is harder than trying to sell a GM seed, and I think this is.
Frank, is yours quick?
I could just, yeah, it will be quick, but I will. This discussion we're having now, or starting to would have the discussion, bears because we haven't really identified why are we doing, or why are we here, why are we doing this, and so what drives it? I never had a single grant or funding from any public source in my life. I can say that. So I made a living for the last 30 years in Australia, driving on my own steam, so to speak. Yeah, I actually have to create funding to be able to do these things I feel passionate about. So therefore, and I have to convince my family to commit to that too. So therefore, the why question in this discussion would be really crucial. If we can identify, have a discussion about why would somebody use biochar, and in which way, and then, I'm delighted the next 2 days will bring that about anyway, this discussion. But the other key word I like to say worldwide is shelter. Even the individual seal needs shelter. Even the individual cow needs shelter. So if we can explain to anyone around the world that with biochar you can produce shelter from the soil, if you just apply it in the soil, you get something going, and then you get the people understanding. So that's all that I want. So those two keywords. Why are we here? And I say shelter is a key word. Yeah, from a microbe onwards, earthworms, you name it.
Yeah, no, I fully agree, and I think why we're here is, we've seen that it doesn't take a lot to move people out of that poverty. So it takes from going from 1.5 tonnes per hectare to 3 tonnes per hectare, and you very quickly move people out of the poverty zone, out of the subsistence zone. And I think that's really what we're talking about here, and it's the win-win scenario of carbon sequestration and food production.
Very good dinner conversation for tonight. I know, I hate to cut it short, but we're already late, so thank you very much.